going to be a review of hydrothermal vent formation, and I fit in the exam questions as well. All right, just to recap, the ocean floor is broken into different plates. Those plates float on the mantle. They float independently of each other, and they float and they move because of convection currents that occur in the mantle. This is the reason for any plate movement, convection currents in the mantle. That hot magma will rise because it's less dense. Cold magma then will sink because it's more dense. And that is going to start divergent boundaries in places where the crust is thin and it gets moved apart from each other. We're going to focus on that kind of boundary when we're talking about hydrothermal vents. As I mentioned in class many times, the ocean floor is not flat. It may appear flat, and that's only because of sediment accumulation at the seabed, and that forms abyssal plains. But we're going to be looking at places where we have mid-ocean ridges, so everywhere where we see like a raised formation. Mid-ocean ridges are only at divergent boundaries. Hydrothermal vents are also only at divergent boundaries. Most common feature that we would see there. Divergent boundaries, generally, these are places where the crust is thin. As the plates move away from each other, magma is going to push up through it, and that magma now is at a very dense, because of high water pressure and cold water, so very dense bottom of the ocean, and that is going to cause the magma to solidify, and it forms new ocean crust. We know this because of the rock ages there, and on both sides of the spreading center, we see patterns that are the same of magnetic reversals. So the divergent boundary, or the mid-Atlantic ridge, rather, going through Iceland. So right up here, you can see the boundary, and then swimming through it. All right, and again, how are they formed? We've covered this in class on Wednesday. There's no pressure buildup here because we don't have any plates moving towards each other. We're not erupting. This was like, I compared it to like a fight, and if people are moving away from the fight, there's no pressure buildup, there's no explosion, there's no eruption. You're just gonna have magma come out and solidify because the seabed is so dense and cold and high water pressure, which is causing that high density. Forms new rocks or new crust. And as, of course, as the crust moves away, or as the plates move away from that new crust area, the divergent boundary, it's going to be forcing plates down somewhere else. So the reason why we have convergent boundaries is because we're spreading somewhere. We have mid-ocean ridges, we have divergent boundaries. Okay, hydrothermal vents. We're not going to be talking about volcanoes and nothing to do with magma coming out. Hydro, water, thermal heat. So this is very, very hot water coming out of these vents. The conditions at a hydrothermal vent. It's a very extreme environment. However, it's very stable, which means it doesn't change. So it's not subject to erosion. It doesn't change because of tides. It doesn't change because of weather. It's always extreme. And organisms can live there. So it is also something that they're able to adapt to. So they're very deep in the ocean, so about greater than 2,000 meters. Water pressure is extremely high at the seabed. That is an extreme condition. There's no light there, and we can call that aphotic. A meaning not, and then photic means pertaining to light. At the vent, the temperature can be greater than 350 degrees Celsius. We're not going to see the water boiling, though, because of the water pressure surrounding it. This one here in the top right, if you look in between these two plumes, you can see like the heat waves caused by all of that thermal energy, or infrared, or like heat energy. It's thermal energy. You can see it, and it looks like if you're looking past a grill, and that's because the infrared or the heat spectrum is disrupting the visible spectrum here. The only reason why we can see any of this is because we bring down lights. Surrounding the vent, the temperature is about 3 degrees Celsius. Now that could be even lower depending on where this boundary is, like on the planet. So if it's in like a polar region or a temperate region or a tropical region, those temperatures could fluctuate a bit, but they're still extremely cold. It's really acidic just due to what's coming out of the vent from what was dissolved in the crust of the earth. The pH is about a 2, so the pH is very low. The salinity is very high because of all these dissolved solids coming out, and that's what you see coming out. It's not smoke or anything like that because it's not combusted, it's not on fire. This is the minerals from the crust of the earth that got dissolved by this very hot water. And this is an extreme environment. All right, for your exam questions, this is the first one. We did do this in class today, and today is Thursday, February 20th, 2025. So if you're watching this any other time, perhaps it's not today. So it says state 2 features of hydrothermal vents that will classify them as extreme environments. This is 2 marks, and you're stating 2. Don't be vague, so we don't want to say pressure, temperature. Like, what is extreme about it? So we're not going to be vague, and do not write more than 2. It will not help you. It's not impressive. It's not a flex. It can only hurt you, especially if you contradict yourself. Your Cambridge graders will read everything you write beyond the 2, but it is not to give you extra marks. Perhaps if you made a mistake on the first or second initial answer that you gave, if maybe your third and fourth answer that you give are correct, it will never help you. But if answer 1 and 2 are correct, and then you put something for 3 and 4, or third and fourth option, and it contradicts one of those correct ones, now you've lost that correct mark. For example, if for number 1, you put really low pH. Number 2, you said it's aphotic, or there's no light. And then you give a third option, and your third option says it's alkaline. Well, the third option could never have given you marks. But that third option contradicts the first one. If something is alkaline, it cannot have a very low pH, which really just tells the grader that you don't know what you're talking about. And, you know, I compare it to like a Hail Mary situation. You're just throwing any kind of answer out there, hoping that one sticks. And that's what this is to prevent, that you're not just hoping that you're going to hit a correct answer, that you actually know what it is the first 2 attempts you have. So we could say it's very low pH, or it's acidic. There's very high water pressure. Notice we're saying high water pressure and not water pressure. And I use a lot of arrows. Do not use arrows on a test. It's very high salinity from the dissolved minerals in the crust. High temperatures at the vent. Low temperatures surrounding the vent. And lastly, there's no light, or we could say it's aphotic. If we consider these 6 answer potentials that I gave, all of these things would make human exploration there quite difficult, especially if we were going there to mine or to take any minerals back with us to the surface and use whatever. It would make exploration difficult. So those answers that we just went over are going to be the same for the question. I believe it's on the back of your paper, and it says marine mining companies are planning to explore the hydrothermal vents. Suggest why the conditions at hydrothermal vents will make exploration difficult. Suggest why command word implies that you haven't gone through this specifically in the syllabus, but you know enough that you can add your own knowledge to answer this question. For example, you need to know the conditions at a hydrothermal vent. but we don't ever talk about mining and why humans exploring there or what we could use the mining for, like how any of that could be difficult. That's not part of the syllabus. But you could imply that because of what you know about the conditions, this would make this dangerous. Okay, there's a big area in how hydrothermal vents are formed. So we're always going to start with the boundary if it's not already given to you. So at the divergent boundary, cold water seeps through cracks in the ocean floor. And if we think back to like, how do I know to start with cold water? Well, think about what you're forming. You're forming a hydro, water, thermal, heat, vent. You need to be making something that is hot water. And we're not starting that way at the seabed. The seabed is cold. So we need to be heating this water up. So cold water will seep through cracks in the seafloor because the seafloor is not flat. Water nears the mantle and it gets superheated. Or you could say it nears the magma chamber or the mantle chamber, or just nears the mantle and it gets superheated. It doesn't boil. It can't boil because of all the pressure. The superheated water now is less dense. Hot things are less dense, and so it's going to rise. It gets forced back up through the cracks in the ocean floor. The hot water is forced through the cracks in the crust. It will dissolve the minerals and the sediment from the crust of the earth as it moves up. It's moving up with such high pressure, and the temperature is so high that it's able to dissolve minerals that make up the actual crust of the earth. From section 1.2, solubility, we learned that solids have really high solubility in hot water. So solids are able to get dissolved as long as they are like an ionic compound or they are another polar molecule where we can have those opposite charges attracting and the electrostatic forces forming. If you have high kinetic energy, that means that your particles are moving really fast and temperature is high. High kinetic energy, high temperature. Or if temperature increases, kinetic energy is going to increase. And it's the kinetic energy of the water molecules. They're moving so fast that their collisions with the salts or the minerals in the crust is at such a high rate, they're going to start to dissolve it just by being attracted to their ions, their positive and negative charges. At the seabed, the water is cold. So now we've dissolved those minerals and we're going back to the seabed. The water is cold and under high pressure. It was going to cause those minerals to precipitate out of solution or solidify. A precipitant, or when something precipitates, it's not about the water cycle in rain. In chemistry, when you have two liquids mixed together and they result in a solid formation, the whole thing's going to turn solid, but a solid will come out of that, then we say that a precipitant is formed. So we have really hot water that has a lot of dissolved minerals in it, meeting really cold water at the seabed. When they meet together, that hot water is not so hot anymore because the seabed is near freezing. It's not frozen. Can't freeze at the seabed, but it's near freezing. And so the precipitant that comes out of that is the solidified minerals. Why does that happen? Because cold water has low solubility of solids. It does not dissolve solids that well. The kinetic energy gets really low, the particle collisions are really low, and they will come out of solution. These sediments are going to accumulate and build up on themselves to form a chimney. The effects from this can be detected at like 50 kilometers away from the actual chimney. And that would be like the minerals that are there and even some residual effects of a lower pH. And in the GIF here, you can see like all that, those white minerals coming out. They are going to start to fall and build on themselves. And that's just an example of one kind of chimney. We would call this one a white smoker. Okay, so furthermore in your exam questions, this is back to the front page of the questions, just like that. Explain why. So you're giving reasons. You got to say why. The water leaving the hydrothermal vent is rich in minerals. So how do we get the minerals in there? We have to talk about dissolving, why the water is hot. So the water at the seabed will sink through the cracks in the crust. We got to get the water hot, right? And it gets superheated by the magma chamber. The minerals from the crust are dissolved into the hot water easily. Dissolved is a common word we need to say frequently. We don't want to say mixed. It's dissolved. And we see it underlined, which means from the mark scheme, it needed to be there. Why does this happen? So we're hitting like the main point of this command word. Give reasons for, or say why. This is your why, because the hot superheated water has a really high solubility of solids or minerals. Slashes again mean you can say this or you can say that. So the hot water or the superheated water has a high solubility of solids or high solubility of minerals. Or you could flip-flop the way you're saying this. You could say minerals or solids from the crust are easily dissolved in hot water. I actually want to get rid of solids and I want to say salts. Why are they at mid-ocean ridges? So what is the mid-ocean ridge condition like that's going to allow a hydrothermal vent to form? They're at divergent boundaries, right? None of that question did not imply that they already told you or you know already, you had to say already that these are happening at divergent boundaries. So you can describe it. Plates are moving apart from each other. We're not saying in opposite directions. Every plate boundary has opposite directions, essentially. They're moving apart from each other, or we could just straight up say this will occur at a divergent boundary. Why? Then explaining the crust is thin, so cold water can seep through the cracks there. The water will get superheated by the magma chamber. And that heated water is going to dissolve minerals, which then precipitate or solidify out of solution on the seabed. So even though you see, like, for some years, some of these questions, the marks they're looking for or maybe are in a different order, doesn't matter. Sometimes they've given 2 marks. You'll see more recent exam question from October, November 2024. An exam question had superheated as a mark by the magma chamber as another mark. And that's nothing we know going into testing scenarios, like, well, what combination are they going to take individual marks for? Then it's not for us to even to know. We won't know until we see the mark scheme. But you can take from this that there's common themes and common phrases and common terms they're looking for when you're describing or explaining these, and that's what you need to be able to incorporate. Okay, in class we did sort these in groups. So we're always going to say, and I can't move them here, but I can at least label them. So at a divergent boundary is going to be our first one. Again, we want to get that water hot. We want it to be hydrothermal, so hot water. Heat the water, and then we need to build up a chimney from all the dissolved minerals inside of it. We want cold water seeps through cracks in the ocean floor. If it's sinking through the crust, what's below the crust is the mantle. Water gets superheated by the magma chamber. Minerals are more soluble with hot temperature or hot water, or in higher temperature water, so the minerals get dissolved from the crust. This is the one I want to say first, actually. Before that, hotter water is less dense, so it flows back up the cracks with high pressure. Okay, and now as it's flowing back up, what are we doing? We're going to dissolve the minerals. Minerals are more soluble with hot temperature, so the minerals get dissolved. Okay, so now we've traveled through the crust. We need to enter seabed. Water reaches the seabed and the near freezing temperatures cause minerals to precipitate out of solution or form a solid. Why does this happen? Because minerals are less soluble in cold water. And the minerals build to, they accumulate, they build up, or they accumulate to form a chimney. Our last two questions. This one is going to be the longest of them. It has a lot of commonalities with the explain question from this past October-November series. It says explain the processes leading to a vent chimney forming at a hydrothermal vent. I also am answering this describe how question as if it were explain. There's nothing wrong with doing that. There is something wrong though with the opposite. If you do need to explain something and you just describe it, then you will not be able to get full marks for that question. But if you go beyond it, it could be okay. So again, we're starting with our boundary. If it's not stated already or you didn't already answer it, then we're going to start there. Cold water seeps through cracks in the seafloor. Water will get superheated by the magma chamber and it's forced up. Why? Because water is less dense. And again, these can go in maybe different orders too, but these are the main things that they're looking for. While the water is being forced up, parentheses, I'm just giving context to the answer. Minerals or salts from the crust of the earth are dissolved into the water. Why does this happen? Because hot water has a higher solubility of solids. At the seabed, the water is cold, and so the minerals are going to precipitate out of solution. They're going to form like a solid. Why does that happen? Because cold water has a lower solubility of solids. And now we need to form chimneys. The minerals will solidify or they will build up to form a chimney. And if you're thinking like, do I need to include all this? It's just 3 marks. No, you don't. You don't. And it would really be a shame to honestly get this as a 3-mark question because there's so much you can write about it. It's like, what was the point of learning all of these steps for 3 marks? So hopefully, if you feel confident about this, and it will all just come from repetition, that will be a question that you could get that's not worth 3 marks. Okay, the most recent question. Explain the processes leading to a vent chimney being formed at a hydrothermal vent. Very similar type of answers. They will be in a little bit of a different order, but similar type of answers. It's not like the science has changed with this. So cracks are formed at divergent boundaries, or you could say there's cracks at divergent boundaries. Due to seafloor spreading, because the crust is thin. Cold water will seep through the cracks in the seafloor. Water gets superheated by nearing the mantle, or by being near the magma in the mantle, or by being by the, I don't want to say mantle chamber. The mantle is the chamber. Magma chamber. Yeah, the magma chamber. Large quantities of minerals or salts from the crust get dissolved into the water. And this is the first time that I've seen this question have that type of phrase, like large quantities of minerals and salts. Do I know if you'll get marks if you don't put large quantities of minerals and salts? I don't know. It's not underlined, so it doesn't mean it absolutely has to be there. But minerals or salts getting dissolved from the crust because that water is so hot definitely needs to be there. Hot water is less dense, so the water is going to get forced back up into the deep ocean. And at the seabed, ocean water is cold, so, all right, for this so far, they said any 5 of these. This question is a total of 6 marks. The only thing we haven't really talked about yet is solubility. I would have included it in the, like, why, explaining why the minerals are getting dissolved into the hot water. That wasn't on the mark scheme. I don't know why it's not on the mark scheme. I would have included it if I were like taking this. It is in the syllabus learning outcomes to reference the solubility of like minerals or salts from the crust at different temperatures. So I would have included it. And you've seen it's been included in other questions, so that should be a good indicator that we should include these. But any 5 of these, and then 1 of these. So the minerals or salts precipitate out of solution. The minerals and salts solidify and they build up to form a chimney. and you need at least one of those statements. So 5 from the top, and then at least 1 from the bottom here. So you need to have at least mentioned something from the bottom at least once about the solidification. Additionally, what's not included down here is the reason why that cold water does not dissolve solids as well. I don't know why. I don't know why. I don't make the questions. I don't make the answers. I just try to make sense of them. I would not take this question as a learning opportunity to say, see, I don't have to say anything about the solubility of salts or minerals when water's hot or when water's cold. I definitely wouldn't do that. But it was not necessary in this most recent exam question from October-November 2024, paper 11. Okay, and that'll do it for the hydrothermal vent exam question.